But today we're actually going to practice writing a couple of functions first, and doing a little bit of programming in C++, and then we will continue on with learning some more new topics. The first thing that I want to talk about is splitting your program up into multiple files. This is just a really good idea for a lot of different reasons. One is for organizational reasons. If you have all of your code that's related to topic X inside one file, it makes it easy to locate code related to that topic. For example, you've already seen this done in Python somewhat, right? All the math functions are in math, right? And so same thing in C++, like all the math functions are in CMath, right? Or all of our string type stuff is in string. So we can include string if we want to use string. Or in Python, if we want to be able to do logging, we just have to import logging. So it saves you from having to include a lot of additional stuff, and you also know what to include. The other nice thing is that it will reduce compile times. If you only have to modify a line of code in a single file, if it's a CPP file, probably the only thing that ends up having to be recompiled is that one file. Whereas if all the code was in one big file, anytime you changed one line of code, you'd have to recompile the entire thing. This could be a very time-consuming process if your project was very large, which a lot of like industrial, level code is. Hundreds of thousands of lines long to get something done. It would really suck if you just changed one line of code and now had to wait 10 minutes to wait for you to be able to test it to see if it worked, right? So we do want to split things up. So when you split your code up into two different files, which this one didn't quite do what I wanted. It's going to split the files up into the CPP, which is the source file, and the header files. So what goes in the header files are only declarations. You got that? Only the declarations go inside the header files, because you're going to have to include these header files later on, and all you need is the declaration to know how to call those functions. If you put definitions inside your header files, you're going to get some errors if you include them multiple times. Because if they're included multiple times, you now have multiple definitions of that function, and you can only have a single definition of a function with a particular signature. So watch out for that. You'll see some examples. The other thing that you're going to see up here is this piece of code, which is already created for you. This is called the guard, and the guard prevents multiple inclusions from having like an infinite inclusions forever and ever and ever. So again, everything that starts with a preprocessor directive, or # is a preprocessor directive, so it's telling the compiler to do something special. So the first thing that we do is we check to see if this symbol over here has not been defined. If it hasn't been defined, we're going to go into this if statement. And the first thing that we do is we define that symbol. Then everything that we want for our declarations is going to go in between, down here in between the end if. This means that if this file gets included multiple times, the first time it gets included, this symbol doesn't exist. And we'll show you an example of this right here. New scratch file. So imagine, right, if I say #include, right, char functions .h. What does #include mean? Yeah, we're going to take what's in that file and we're going to copy and paste it here. So what this line of code translates into is a copy and pasting of this code here, right? So now imagine I had done it again down here, right? So it gets copied and pasted down here. So we go through our piece of code and we check to see if this symbol has been defined yet. So has this symbol been defined yet? No. So we're going to go inside this if statement. The first thing we do is we define that symbol, and then we would go and we'd have our code in here, which again is only going to be the declarations. Then we reach our end if. Then if we had this accidental second include, we check to see if this symbol has been defined. Has it? Yes. So we do not do any of this code inside here. So the compiler will not translate any of that code at all. it just skips over it altogether, like it doesn't even exist. And while you probably won't ever see inside, your assignment where you accidentally pound include the same function or the same file twice in a single file, you may have it where you include some other file, right? And that file like, let's say you include a.h, and a.h includes b.h. You also need b.h, so you include b.h as well. Well, now it's just been included twice. Because when you include a.h, it copies its contents inside. So it copies inside the include of b.h, and then you attempt to include b.h again, so you now have it there showing up twice, which would cause issues, because if the guard wasn't here, you'd have this infinite loop where you possibly could keep including yourself over and over and over and over and over again. The file would get infinitely big, and it wouldn't work. So that's what the purpose of the guard is here. It's to make it so that we don't double declare something. Any questions on that? Yeah. Yeah, it's just these three pieces of code. And so when you're going to be writing, CLion will automatically generate this for you if you create a header file. So you don't have to worry about writing it. The other thing that's important is that this symbol over here needs to be a unique symbol. And so most often, the symbol name is going to be based on the name of the file, because the files also have to be unique. So you can see that the name of my function is morestringfunctions.h. So we have morestringfunctions, which is the name of my project. The name of the file, morestringfunctions_h. Anything else? So what I first want to start with is writing a couple of functions based on characters. These already exist. They're already inside CC type. So but we're going to write them ourselves. One thing to note is if you ever see a file whose name starts with additional C, like C math or CC type or C time, that means they're all C-based header files. And so we're actually using C code and not C++. They'll still be fine. So the first function that I want to write is going to be is upper, and it takes in a character C, and it checks to see if C is an uppercase character. We're also going to do is lower. Is alpha. Is numeric. Is aldum. To upper and to lower. Also, you can see this looks a little bit ugly. If you do Control-Alt-L, it will automatically like reformat everything for you to make it look a little bit nicer. Any questions so far? Checks if it's an alphabetical or numeric character. So again, notice that in the header file, all I have is the declarations. Another shortcut that you can do here in CLion is if you have a declaration, you can hold Alt and press Enter, and it will give you the smart prompt, and you will say generate definition, and it will go and create the definition of that function for us so that we don't have to retype it out. So how can we, this function should return true if C is an uppercase character. So how can we check to see if C is an uppercase character? Yeah. Uppercase letters and lowercase letters do not have the same numeric value. So if we look at the ASCII table, again, you can see that A goes from, uppercase letters go from 65 to 90, and lowercase letters go from 97 to 122. So no, they don't have the same values. No, because we're going to be having to write to upper later on. So you could use to upper, but if you use to upper on the character, wouldn't it always be uppercase? And here we're trying to check if it is uppercase. Oh, I guess you could do it as that. Or if another way that we can think about it might be what? Mhm. Yeah, so we could check more or less like is C greater than or equal to 65 and is C less than or equal to 90. This works, but a much more like easier way to understand it is, come on. Well, is it greater than or equal to A and less than or equal to Z? Right? It's the same exact check as what's being done, but I would argue that this one's a little bit more understandable, right? You're an uppercase character if you're between capital A and capital Z, right? And we know this is going to work because capital A and capital Z are right next to each other. One thing to watch out for is you cannot do this in C. You cannot do this. This is illegal, or not illegal, but incorrect. This doesn't work, even though it does work in Python, so I want you guys to watch out for that. This equality comparison by putting something like in between two values works in Python, but not in C and C++. How this evaluates is first we do it like this. First we evaluate is A less than or equal to C. And then we check to see if that is less than or equal to Z. So, right, A less than or equal to C is going to evaluate to be what? Can either be true or false, right? So this ends up being something like true or sometimes false, right? I'm not sure which one it's going to be. It depends on what A is. Is that less than or equal to Z? Do you guys remember what's considered to be true and what's considered to be false? So normally zeros and ones is kind of the answer I normally get, but technically a value is considered to be true if it's not 0, and 0 is false. So 0 is false, everything else is considered to be true. But when we do an evaluation of a comparison like this, the true value will be 1. So here we're going to have like 0 or 1 is less than or equal to, right, Z. But if we look back at Z's value, capital Z's value is 90. So we end up with, 0 possibly or 1 is less than or equal to 90, which is going to be, it's always true. So it's a great way to write true. If you turn on the warnings in the compiler like we talked about last time, by adding this little bit of code down here, right? Target compile options, the name of your executable, private -wall -error, the compiler will warn you about this mistake and you'll be able to catch it. Otherwise, it will just report the error but compile anyway, and then you have something that always returns true and you're very confused. Any questions over here about is upper or the comparisons? Another quick question is, what do you think A plus 1 is? Does not return an error. Well, I mean, it'll be ASCII value of A, which is 65, plus 1, which is 66, but 66 also happens to be B, right? So it's 66 if you want to consider it to be a number, or B, right? You can also do something like this too. You can do something like C, minus A. What do you think that's going to be? Right, so we have A, then B, then C. So C is 2 letters after A. So if you want to know like how far a character is like into the alphabet, you can do like subtraction right here. Any questions? Okay, so is lower. What do you think we should do? Oh, that shouldn't be an, yeah, no, that should be an and. So is lower. Well, C has to be greater than or equal to little a, and C has to be less than or equal to little z, right? Kind of extends from is upper. Is alpha isn't an alphabetical character? Yeah. Yeah. But is alpha is only alphabetical characters? 0 and 9 are not. No, that'd be is numeric. Or like is digit would return true between 0 and 9, right? We want like a letter A, B, C up through Z. Yeah, right. So we can just check to see, oh, is it a lowercase character? Or is it an uppercase character? If it's an uppercase character or a lowercase character, it must be an alphabetical character. Does that make sense? So I'm going to change this one to be from is numeric to is digit. As was suggested earlier, we could just check to see if it's between C has to be greater than or equal to 0, and C has to be less than or equal to 9. Is that correct? No, what's wrong with it? They need to be character 0 and character 9, right? If you look at numeric 0 is null. Numeric 9 is a horizontal tab, right? We want to make sure it's between numeric 0 or character 0 and character 9. So let's make them characters. Is alnum? Is it a alphabetical character or a numeric character? So, right, just is alpha C or is digit C, right? That gets you alphanumeric. And again, these are all inside CC type, so normally you wouldn't have to, write them yourself, so you can just include CC type and they exist. What about 2 upper? Well, you're on the right path, but there's some things we have to consider first. Like, what's the uppercase version of 43? I mean, not 43. The uppercase version of the plus sign. The plus sign. What's the lowercase version of the plus sign? The plus sign. The only things that have uppercase and lowercase versions are letters. So we should probably check to see if it's an alphabetical character first, right? So if is alpha C, right? And even then, we don't even have to check if it's a alphabetical character. We just have to check. The only things that we want to make, the only things that we want to change are lowercase characters. So if it's a lowercase character, what should we do? And then otherwise, if it's not a lowercase character, what should we give back? Yeah, just return C. If it's not a lowercase character, it's already the uppercase character, and so we don't have to do anything. Now, how are we going to get the correct uppercase character value? We can do some subtraction, some addition. Yeah. Mm-hmm. Mm-hmm. You could modify C in the first if statement and then do a return. That would work because it's not const. And remember, this is a copy of C, so you're not actually going to be changing the original. You're going to get back a copy that is the uppercase version. If we wanted to actually be able to modify C itself, we would need this to be a char reference, right? And then we'd be able to change the original that we were given. Oh, so the question is, what happens if you pass in just a character, like a constant value, like A, Would that work? No, C will complain at you that you cannot have a reference to something of, let's say, right-hand side value. Something that can only show up on the right-hand side of an equal sign. So if you're passing something that accepts a reference, it has to be something that can show up on the left-hand side of an equal sign, which would be a variable. Now, if you declare your function as accepting a const reference, you can take things that can show up on the left-hand side of an equal sign or the right-hand side of an equal sign, right? Because if it's a const reference and you pass in like the string literal, the character literal a, it would work, right? But if you don't have it as a const reference, it actually has to be something that you can change. Yeah.
So, let's say we pass in first, like a virtual best for
so when we take it in as a const reference, probably what will happen is we will get a copy of the variable, more or less, at that point. But again, since you have a const reference, you would not be allowed to change the thing that was passed in, because it's const. But what can we do here to make our lowercase character an uppercase character? Yeah, we can, but like, so if you think about it, we needed to figure out two things, right? Or if we knew how far this character appeared to pass, like little a, right? Then we would know how far to go into the uppercase alphabet. No need for a for loop. We can just do this purely with subtraction and addition. What we could do over here is we could see, again, I just talked about how we could see how far past a letter came past another letter. So we could do something like, oops. So C minus, C minus A, right? That's going to tell us how many characters past lowercase a we came. And we know that we're a lowercase character, so that's fine to do. So like if we were lowercase c, we'd get 2, right? And so now how far into the uppercase alphabet do I want to move? 2, right? I want to go to uppercase C. So you would do something like A plus C minus A, right? Just, for clarity, this C minus A tells you how far past the beginning of the lowercase alphabet you are. This part right here says go however far past the lowercase alphabet you are past the uppercase alphabet. So if we do something like this, let's say our lowercase letter was D. D minus A is 100 minus 97 is 3, right? Now I do 3 plus uppercase A. Uppercase A is 65. 65 plus 3 is 68, which is the D, right? But again, even if we don't think about the ASCII values, and we kind of think like, oh, this is going to give me a number, how far past I am past A, well, I need to move that same amount past big A. Does that make sense? Yes. Little a is 97, so you could replace this with 97, and that's going to work. But I would argue that's really confusing. What does the magical number 97 mean in the context of this problem? But A, that's a little bit easier to intuit as to what's actually going on here. And again, if things were still confusing, we could add comments. Right? We could do something like C minus A is how far C is into the lowercase alphabet. We then need to move that same amount into the uppercase alphabet. Any other questions?
Alpha.
Lower. The 2 pipes mean or. The two ampersands mean and.
How do you,
like, how do you write them?
Yeah.
They are the key right above your enter key, and you have to hold shift to be able to do that one.
Originally.
No, they're not. They're the same. They're on the same key as the backslash, but you just have to hold shift to get to up here, right? Right. Like this one is like this. That's the backslash character. If I hold shift and press it, it goes up as the or. And then to lower, right? We could probably do the exact same thing that we did with to upper, but in the opposite order. So like if is upper, C, right? Return little a plus C minus big A. Else return C. Any questions here with any of these functions? Any of the syntax? Yeah. Yeah, the curly brackets are the indentation. So everything that's inside this curly bracket is a part of this if statement. Still use indentation because I think it's a lot easier to read. But the else is right here. You're talking about like else if? There is one. Right down there. Parentheses around what? No, because like if I do like 3 plus 5, minus 6, isn't that the same thing as doing 5 minus 6 plus 3? Right? The order of the additions here doesn't matter. The only reason I did the parentheses here above was to give you like an illustration of what my intent was, right? But whether I do like big A plus C minus A, or I do C minus A and then add uppercase A, I'm going to get the same answer. Any other questions? Yeah. So there is a toLower function in the CC type header file, but we're making our own function who has the exact same name, and I won't be including CC type. Yeah. So notice there's two separate files, charfunctions.h, charfunctions.cpp. The header file has the declarations. The CPP file has the definitions. Notice also that I had to include this, I include my header file in my corresponding CPP file, which again just means copy and paste the contents of this file. So I'm going to get all these declarations at the top of this file here. If you need other types, for example, if we needed strings, and we only needed strings in the implementation in the CPP file, we would pound include string over here. Or if we needed vector, we'd pound include vector. If that type shows up in the header file, though, as like either an argument or the return type of a function, you will also need to put it in the header file as well as an include, which you'll see in a little bit. The other thing to note is that for user-defined header files, they get enclosed inside quotation marks as opposed to being enclosed inside the triangles. Right? So if you're including your header file, quotation marks, including a system header file in the triangular brackets. So now we'll switch over to strings unless you guys have more questions. So maybe the first thing that we're going to create is called a void lower in place. And what I want this to do is to accept a string and to make it all lowercase, but to modify the string that's been given in. So what would my arguments type be that I should accept so that I can make this string that I'm passed in all lowercase? Should be a string reference, right? std : string reference, and I might call this string. Now, one thing you're going to see, it's like I don't know what std is, and that's because over here we're referring to the type string. But if I want to refer to the type string, what do I need to do? Where's the definition of string at? In string, right? So we need to, how are we going to bring that in? Include it, right? So pound include string, right? And so notice that the string is on part of the system library, so it's inside the triangular brackets instead of the quotation marks. Any questions so far? Yeah. String. Can you ask that question again? Uh-huh. Is string a dependency for the STD library? So STD, like the STD, is not a library, it's a namespace, which again, we'll get to that later on in the class. So no, we don't have to include any other files to be able to use string here. Just include string if you want to be able to use string. Yeah. Like, why do the system libraries use the triangular brackets while yours use the quotation marks? Yeah, so for any header files you define yourself and you include them, they'll be enclosed inside the quotation marks. Anytime you want to include a system library, it'll be included inside the triangular brackets. The difference between the triangular brackets and the quotation marks is where the compiler looks for that file at. The triangular brackets is going to look on the system include path, whereas the double quotation marks will be on the project include path. And by default, the current directory is a part of that path. So integer is a built-in type, so you don't need to include anything to be able to use int, char, float, double. But string is not a default type, so you have to include it to be able to use it. Yeah. So you can, this is if not defined, this symbol, define this symbol. So define just means create the symbol. Currently, it's just a symbol that exists that has no value. Mm-hmm. Anything else? Okay, so let's go write this function. So over here, what function am I probably going to want to be able to use inside of this function? ToLower, right? And where is ToLower defined at? Depending on what, either CC type or our char functions. We're going to assume it is in char functions. So since I want to be able to use that here, I have to include char functions.h. If I don't include char functions.h, I won't be able to use it inside this file. I don't need to put it in the header file though, because inside the header file, I do not refer to anything inside char functions at all. So how can we make everything in this string lowercase? And we want to modify the string that was passed in.
I have to separate them into characters.
So we have to go through each of our characters, right? And make each of them lowercase. So how can we go through each of the characters? For loop, right? And we have a couple of different options that we could choose. We could choose the element-based for loop. We can choose the iterator-based for loop, or we could use the like range-based for loop, I equals 0, I less than size. Which one do you want to do? Element, like for each element. Do you want to use for I equals 0, I less than the size? Or do you want to do the iterator-based version? Oh, why don't we just do all three of them just so you can see what it looks like? So the first one would be the element-based for loop, which would be my preferred method. So for, how do I write this? So we have to specify the type first, right? And so what's the type of each element? Char. And then we have to give it a name. And so we might call it like, letter, right? And then how do I write in? Colon. In what? What's their container? String. And what do I want to do? Not search. I want to make each letter. Right? So how do I say each letter is equal to its lowercase version? Right. So we have like 2 lower letter. Is that good enough? right? We have to say letter equals to lower, right? Because remember, to lower doesn't actually change the character that's passed in. It returns a copy of the lowercase version. There's also a small bug in this piece of code. How small? As in, one thing is missing. Oh, there's a colon there. Semicolon's there. We've included char functions so we can use to lower. We don't have to check whether it's alphanumeric or not because to lower will leave the character alone if it's not a lowercase letter, right? If we try to lower an exclamation point, remember our code back here, right? You would just get back the exclamation point because it's not an uppercase character. So that's not the issue. No, notice our return type that we specified is void, so this function shouldn't return anything. You can have a return statement in a void function. It would just be return. So if you wanted to, you could type, just return down here, but it's doing the exact same thing as before, where it would automatically return. Yeah, letter should be a reference, right? Because if we don't make letter a reference, what's it going to be? A copy. So what did I do? Just changed all these copies, right, to be uppercase versions. And then as soon as I get through this for loop, what do I do with the copy? I throw it away, right? I don't need it anymore. Get rid of it.
I thought by using letter equals lower.
So over here, yes, this part right here returns the uppercase version of letter. But this guy over here before, this guy is a copy of the letter in the string because I don't have a reference to it, right? By default, if you just have a type name here, it's going to be a copy of the element in the container. So I'm changing this copy of the letter in the string to be its uppercase version. Now this new uppercase version, toss it, right? It's gone. I don't need it anymore because it won't exist after the duration of the for loop. Same thing would probably happen if you wrote this same code in Python, right? But now if I have a reference here, then I'm going to be all good because I actually have a reference to the character in the string. And so I'm going to go into that character in the string and make it uppercase. Yeah. No, so you're saying, like, is this okay? Oh, you want to put it here? Again, like the white space doesn't really matter in C. So this is the same thing, and this is the same thing. But I like writing it like this. I like putting the reference with the type. That's just my personal preference. Any other questions here? Yeah, if you did the same thing in Python, right? If we did something like def make upper, right, some string, and we said for letter in string, letter equals letter dot to upper, or it's just upper in Python, right? Right, pretty much the same piece of code, and then here's my, A is equal to, and if I say like make upper A, well, A is still lowercase. There's two different reasons for this in Python. One is that strings are immutable, right? You can't change them once they're created, right? You can't change the elements inside the string. And the other reason is over here, again, you would get a copy. So even if we have something like this, like def add 1 in Python, and we have some list L, and we say, for val in L, right, val plus equals 1, and then I make my list over here be 1, 2, 3, and I say add 1 to H. What's H going to be afterwards? The exact same thing. Or even if I do it out here, even if I say for val in H, val plus equals 1. Oops. What's the value of h going to be? The exact same thing, right? Because in Python, when you iterate through the elements using the iterator-based or the element-based for loop, you always get a copy of the value. In Python, you would have to do something like for index, or maybe you want like index for I, comma, val in enumerate h. H at I is equal to val plus 1. And now if we look at h, now they're all by 1. You'd have to use the index to go inside of it to update. Yes? So you can read the colon back here as the word in Python. So for each letter in the string, but use colon instead of the keyword in. Yeah, right? The syntax is a little bit different. Any questions here? If we didn't want to be bothered to figure out what the type of the elements inside the container were, what could we do instead of using char?
Auto.
We could use auto here as well. And again, like my normal preference is just to have the compiler deduce the type for me, so I don't have to think so much. But again, char, auto, same length, you could use either one. Yeah, well, the compiler will figure out that the type of letter is char, and it will replace auto with the word char. So I end up with char reference, just like I had before. Can I replace void with auto as well? You should be able to replace the return types of the function with auto. But I tend not to do that. I tend to be very explicit with the return type. I'm fairly sure we could do auto here, and it's going to be like, oh, I didn't. I changed this one to be auto. Yeah, I guess it's happy with it, but I still prefer to be explicit on my return types. There are some times, where I don't like to be explicit, which is normally when I'm working with templating or very long types, but I'll show you examples of those later on. So let's say we wanted to use the for I equals 0, I less than the size version. Well, that would look like this. For int I equals 0, I less than string dot size, right? Plus I, letter, string dot at I is equal to string dot at I, but then we need to do two lower on this. And you can probably see why I'm not sort of a fan of this one here. So this would be like in Python saying like for I in range length of thing, right? My element at that index is equal to the two lower of the element at that index. Not a big fan, but it does get the job done. It says like here, use range-based for loop instead if you're going to go through each of the elements, and I kind of agree. Final version would be the iterator-based version, so for, and so like if you want the type of the iterator and you don't want to use auto, it's kind of annoying. It would be std : string : const iterator. Iter equals string.c begin. Iter doesn't equal string.c end plus iter. And this is when I was going to say star iter is equal to two lower star iter. Oh, whoops, this is, I can't do a const iterator here. This has to be a iterator. This needs to be begin because I'm trying to change the elements, so I can't do it with a const iterator. Say it again?
For the second, for int I.
So the at methods on the string give you back a reference to the object. not a copy of the value. So this allows me to actually modify the element inside the string. Again, I don't like writing this thing right here because that's pretty long. What this is saying, right, is we have string, which you guys have seen before. The string has another type inside of it called an iterator. So this is the string's iterator, which is what we would need to get an iterator to go through the string. I don't like doing this one, so I normally would just use auto, right? And so you could have auto here instead. That's what I'll put here in a comment. Right, that's why I think iterators are a great place to use auto, because it's very clear that you're getting an iterator, and you don't want to, type out that gigantic thing every single time. Any questions? Yeah. The plus plus is adding. I'm assuming you're talking about the plus plus here on the iterator. We will get to this later on, but you can make plus plus mean different things on different types. And so plus plus on an iterator means go to the next element in the sequence. Yeah. Yes, so the type of auto would be deduced to be whatever begin returns. And so if we look back here, if we look back here at string, and we go to begin, right up here, and we come back, and you can see that the return type over here, as it says, it's an iterator, right? And if which it's a strings iterator, is what begin returns back. And if we look back here, you can see that it defines iterator inside of the type of it. So std : string : iterator is the return type of begin. The thing that we've written over here. Yes? No, so remember that this piece of code down here in the update section runs after the body. So first we set our iterator to begin. That happens once. Then we check to see if we're at the end. Then we run the body. Then we do the update. Then we do the check body, update, check body, update, check body, update until we finally leave the loop. Wouldn't matter if it's pre or post increment. Sometimes I think it supports both, but normally it's much more common to do a plus plus than plus plus iterator than iterator plus plus. But either one should work, and we can even try it out. Oops. Come on. All right, we're not gonna have any difference. Yes. So an iterator is sort of like a pointer, but it's not a pointer, and so it will not always have the address of the thing. So you use the star operator, the dereference, to access the value the iterator is at. So like the iterator right now is like a position, and so if I want the value at that position, I have to put the star in front of it. Correct. An iterator does not have to be a pointer to like internally. It doesn't matter how the iterator is implemented, whether it's a pointer or not. The dereference operator on all iterators is how you get their value. And again, we will talk later on in the class how we can define the meaning of the operators on our own types. Oh, I should say, you do not get the value, you get a reference to the value. Is what the dereference on the operator, the dereference on the iterator does. So then I'm able to change it. So all three of these are equally valid. Take your pick on which one you like. After you've seen them all, who prefers the element-based, like the first one, version number 1? Who likes version number 2 the best? Who likes version number 3? Okay, right? So you can use your preference. They all do the exact same thing. Do which one you feel most comfortable with, but continue to practice with all of them so that you're able to use them. I will see you guys later tonight. We'll continue working on our examples.
Well, for the last one,